Welcome to the lecture on weather basics. Share my screen and weather. So weather is a combination of different environmental conditions, and in order to observe weather, we're trying to see things that we can't necessarily see with our eyes. In other words, making the invisible visible. So first, what is weather? It's the conditions of the atmosphere at a certain place and time. And we're talking weather on Earth, obviously. And it's not the same as climate. Weather is what's happening today, what's going to happen tomorrow, what happened yesterday. Weather is more of a right here, right now, in the moment, or a very short window of time, what really happened, or what is our best estimate of what is going to happen. Climate is a pattern of weather events. Climate is the long-term seasonal types of things that happen year after year, and climate does move. It shifts over years, decades, primarily over many decades or centuries or even millennia. The climate can change significantly or it can stay relatively stable depending on many, many different factors. Here in the central coast of California, we have a Mediterranean climate, a very modest, mild Mediterranean climate that is influenced by the Pacific Ocean. And that keeps it similar to the European Mediterranean region, depending on where you are. The Mediterranean climate has relatively mild conditions, relatively uh, dry summers, and um, a pattern of rainfall that is mostly condensed into the winter and spring months. And again, that's because of the influence of the Pacific Ocean. And depending on where you are, the Monterey Bay has a huge influence on the Salinas Valley and our immediate area around Salinas and other places around here, Watsonville, Santa Cruz, uh, even going down into Hollister, or excuse me, not Hollister, King City and San Ardo, etc. Um, Not to discount Hollister being influenced by the Monterey Bay, no doubt it is. It's just not as a direct path of the weather conditions and climatic patterns over the year. And other places, deserts, high mountain areas, they have different patterns. Some places freeze, some places snow, some places have very hot deserts, some places have very low humidity, et cetera, et cetera. And it's those patterns that we need to look at, the climate, in order to make good decisions about what we're going to do moving forward. And it's only in the short term and the here and now that we talk about weather. So, what are the things that we can measure that we can't actually see? So, here's a list of things like temperature. We can use a thermometer or a thermistor, a type of measuring device that measures temperature. And we can measure pressure. In this case, we're talking air pressure or barometric pressure. The air pressure is very important when you're looking at what the weather is now and what the predictions are for the short term in the future. So, for example, you might have seen the weather reports on TV, on the newscasts, and you see these big H's and L's off the coast of California or other places around the country. The H represents a high pressure zone, and the L represents a low pressure zone. And when we move into lower air pressures, the weather tends to be going towards rain and wind and other things as other air moves into the void, into the lower pressure. Other high pressure areas flow into it, bringing in potentially moisture and wind. The high pressure tends to hold things out And so the high pressure is holding on to whatever conditions, and it tends to stabilize and make the air movement much less uh, volatile, much more stable and stagnant. And so it heats up. And so when we get high pressure hanging off the coast of California, we end up getting very dry periods, maybe hot periods during the right time of the year. For a long enough period of time, a high pressure can really cause some serious heat waves in California. So the air pressure is very important, measured with devices such as a barometer. Then we have wind speed and wind direction, which way is the wind blowing and how fast. Moisture, it's measured in terms of humidity. It is a percentage of total capacity. We'll get into that. But what is the capacity for air to hold on to moisture? And the dew point is when you hit that 100%, and it will start coming out of the air. The moisture will come out and get dew or droplets of water starting to form on things. Clouds, well, we can certainly see the clouds, but there's not only the percentage cover of a cloud, but also the types of clouds, the density of the clouds, etc. Precipitation is anything that is falling out of the sky, that is coming out in the terms of rain, snow, sleet, hail, freezing rain, etc. Anything with many different kinds of names, depending on where you live and how detailed you want to describe it. All of these things that come out of the air are called precipitation. We also use that word in chemistry. So if I'm doing a chemical reaction and something becomes a solid after it was once soluble, that solid precipitates. So I can make, for example, a very highly saturated sugar solution and stick a string into a jar of high concentrated sugar solution and forget about it for a little bit of time, come back, and there will be salt crystals precipitated on the string. That's how you make rock candy. And you can add color and flavorings so you can make all kinds of interesting rock candy. It's a precipitate. It's something that came out of solution. So in weather, we're talking about moisture that is evaporated and part of the atmosphere, that conditions have changed. Either it's gotten colder, more condensed water, whatever the conditions are that caused the moisture to collect into some form of raindrops or snow or hail and fall out as precipitation. And then there are other special conditions and changes. This is going to be an extremely minimal type of presentation on weather, but it's the things you need to know. So let's look at them one at a time. And some of them are pretty obvious, and you just need to know for a test, for example, what are the names of the measuring devices. We measure temperature with a thermometer, and there are lots of technologies that can do this, from just a liquid inside of a narrow tube, or mercury, which isn't used too much anymore. It's very accurate, very useful for scientific instruments, but mercury is not used in home instruments or typical industry devices that don't need the mercury, because mercury is toxic. And so there's a lot of effort to reduce the amount of mercury use. So you have a thermometer here, a thermometer combined with a humidity gauge, which is very common in an electrical gauge. Be careful, though, about trusting something just because it has digital numbers. That doesn't mean it's accurate. Any device can be made to spit out a number to you, and you can look and read the number and believe it. Don't believe it. One of the things I've learned in my lifetime is I never trust anything. Always get quality equipment and always calibrate it. Always double check it. Always make sure it really is doing what it's supposed to do. Have backup units to make sure that they're both measuring the same way periodically. But anyway, that's true of all instruments, not just thermometers. Pressure, I mentioned that one already. They're measured with barometers. Um, and they can have metal coils that actually use uh, uh, the pressure in the atmosphere to move a metal coil, moving a either analog needle or some sort of a digital display, but you're measuring the barometric pressure. And there's a number of different ways to display this. It's often displayed in millimeters of mercury. Pressure can be measured in pounds per square inch. That's not what we typically use in weather. We usually use millimeters of mercury, but there are other types of measures that are also used in air pressure. Not going to worry about it for this. Um, uh, you just need to know what type of unit your air pressure is being measured in. We've already spent enough time talking about high and low pressure. Wind speed and wind direction. So there are two paired devices that you see here. Wind speed is these little half eggshell cups on a very sensitive bearing. And it's pretty simple in concept. You have a balanced set of magnets. Usually there's 4, 6, 8 magnets, an even number of magnets that are in a circle, balanced very carefully in a very sensitive ball bearing setup. And as the wind hits these little cups, it causes the whole thing to spin on a little shaft here. And the spinning shaft causes the rotation of these little magnets. And so all you need is a little sensor off to the side, just a little wire with a sensor off to the side, measuring or counting how many pulses of the magnetic field it gets from the magnets going by. And then it's just a simple math problem. How many, how many pulses, if it's 6 magnets in the circle, 6 pulses means 1 revolution. And what is the diameter of this device? Blah, blah, blah. You can calculate how many times it spins based on the magnets and how much distance that means. And the only other thing you need is a clock, a very simple timer. So you're counting how many times are you counting the magnet spinning over a period of time. So if it's giving you 3 feet per second, calculated by the magnets going by, you can calculate that up to how many miles per hour that would be. Again, very simple calculations that can be done. The important part is having a quality device that's well calibrated. And then the wind vane always points into the wind. So the vane portion always goes downwind. The wind is going to push this large flat piece downwind, and the wind is going to be blowing into the nose, this little pointer here. And so when we talk about wind direction, if I say there's a north wind, that means this little pointer here on the vane is pointing north. The wind is coming from the north, heading south. So a north wind is coming from the north, heading south. Kind of like an offshore wind, which we usually have here. An offshore wind doesn't mean the wind's blowing off the shore. The wind is blowing from off the shore onto land. So it's the way we always talk about wind from where it's coming. The speedometer of the wind speed is measured by a device called an anemometer. So this little device that I described moments ago is called an anemometer. That might be a term you've not heard of before. You've probably heard of the vane, a wind vane. A lot of people have a simplistic wind vane sitting up on their barn or somewhere around the house, maybe an old chicken, and the chicken points in a direction and it moves on your roof to tell you where it's going, or maybe you have a wind sock And a wind sock not only tells you wind direction, because the sock always goes down the wind, but it also can tell you speed. If you look at the instructions that should come with a wind sock, depending on the angle and how much of the sock is straightened out, it can give you a pretty good gauge of wind speed. But it's just a very approximate thumbnail. But it's still very useful. We used to have big wind socks in important areas around places that I've worked, and it was really useful. I can tell from 300 yards away approximately what the wind speed is without having to worry about getting on the radio and asking somebody for a more accurate measure. And if we're spraying chemicals or we're doing anything that wind speed is important, knowing that is handy. I've also worked in facilities that have poisonous materials such as agricultural chemicals or coolers that use ammonium, anhydrous ammonium, or ammonia, excuse me, anhydrous ammonia as the refrigerant. And if there's ever a major leak or something, first thing you would do, if there was any concern, look at the windsock. And whatever way the wind is blowing, you tell everybody, we're going to go to safety over the other way. Wind's blowing south, you get the troops together, the employees together to make sure everybody's safe on the north end of the facility. So let's take a quick break, and I'll be right back.